Great. So now let's look at another trig example. So integral x squared over square root of 9 minus x squared dx. This 9 can be rewritten as 3 squared. So this belongs to one of the trig substitution type, right? So which is a squared minus x squared. So this is gonna be the right triangle we need to draw, and this is gonna be the correct substitution we need. Okay, so let's follow that. We draw a right triangle here, theta, and so this is 3. It's going to be x. It's going to be square root of 9 minus x squared. And correspondingly, the substitution I need is x equals 3 times sine theta. Okay, and corresponding dx is 3 cosine theta d theta. Okay, so 9 minus x squared is 9 minus 3 sine theta squared, so it's 9 sine squared theta. That is 9, 1 minus sine squared theta. That is 9 times cosine squared theta. As we mentioned in the trig substitution video, so when we have this type, our theta will let it belongs to negative pi over 2 to pi over 2 here. Okay. So that will also give us cosine theta is greater than 0. So with those, we can make our substitution. So x is 3 sine theta. I have x squared, so I have 9 times sine squared theta. On the bottom, I have square root of 9 times cosine squared theta. And then dx, which is 3 cosine theta d theta. Okay. And turns out this is going to be 9 times sine squared theta over 3 cosine theta. Okay, times 3 cosine theta d theta. So, right, because cosine theta is positive, you can cancel those two. Turns out this is what we have. We have 9 integral sine squared theta d theta. Okay. So up to here, we're gonna use one of the trig identities to decrease the degree of this term, because this is sine squared. We want to use this trig identity, which is 1 minus cosine 2 theta over 2 d theta. So as you can see now, there is no square getting involved. Okay, and so if I bring those 2 out, so it's 9 over 2 integral 1 minus cosine 2 theta d theta here. So the integral for those are very straightforward, which is just the theta minus sine 2 theta over 2, okay, plus a constant c. Okay. Right. And then we only know the trig function involved with theta, and we have very, very little knowledge about the 2 theta things. Okay, so from here, I'm gonna apply another trig identity, which is sine 2 theta equals 2 sine theta cosine theta, and then over 2, and then plus constant c. So now you're gonna have this 9 over 2 theta minus sine theta times cosine theta, and then plus the actual constant c here. Okay, so basically the 2 trig identities I'm using is sine squared equals 1 minus cosine 2 theta over 2. So this is 1. And then sine 2 theta equals to sine theta cosine theta. Okay. And then correspondingly, I need to figure out what theta is in terms of x. What is sine theta? What is cosine theta? Well, let's go back to what we have here. So we know that sine theta is x over 3, right? And then cosine theta is square root of 9 minus x squared over 3. Okay, from here, sine theta equals x over 3, and then my theta belongs to this interval, so that actually can guarantee I have an inverse for this. So theta can be written as sine inverse x over 3. So now I have everything, so I can just substitute everything back. So I have 9 over 2, theta is sine inverse x over 3, okay, minus sine theta is x over 3 times the cosine theta, which is square root of 9 minus x squared over 3, and then plus the arbitrary constant c. So and then we finish this problem. Okay. So the key is still to draw the right triangle, make the correct substitution, and then simplify. Of course, in the middle, you're going to use those two identities to help you. And then to the very end, don't forget to substitute theta back with x. And then again, how do we substitute it back? It kind of goes back to the original triangle we have. So what is sine theta, cosine theta, and how to solve for theta? It's very obvious, okay, if we do this part correct. Okay, so I hope you enjoy this video, and I'll stop here. Thank you.